I am Anil Kumar. Welcome to my series on calculus. Now, in the second part, we'll begin with integration. In part 1, we talked all about differentiation. Now, integration is kind of reverse of differentiation, so we have given the title integration as well as antiderivatives. So, this is a reverse process. We'll try to understand the concept of integration. As we know, it is reversing differentiation or antiderivatives. That is how you can integrate. But with this, you get indefinite integrals. You're not very sure about the solution. So the graphs here kind of indicate that when you're trying to find integral of a function, at times you get family of graphs which are translated vertically as shown here and which are parallel. But if you're given a specific point on the graph or boundary conditions, we can actually find specific solution. So we'll look into how do we find specific solution by antiderivatives. Then we'll understand the integration of power functions, basic rules related to sum and factor rule. We'll take up examples with power rule, integration of binomial powers, and we'll have some exam practice test examples. So let's begin with the very basic concept. So when I say introduction to integration, we just want to understand how can we connect this to what we have just learned in calculus. So in first part of the calculus, our focus was to find the derivatives, right? Which is gradients or rate of change. But many important applications and the laws of nature involve reverse process to find the original function when its derivative or rate of change is given to us. Following are the examples. Law of exponential growth. The rate of growth of population is proportional to the number y of individuals present. So rate of growth is dy dt. It is proportional to y. You could write this as dy dt equals to k times y, a constant times y. So as you can see, it's a very common scenario. Law of exponential growth. We are given the rate of growth and we need to find the individual numbers, right? So it's a reverse process. Similarly, gravitational constant near the surface of the Earth affects the rate of change of velocity of the object falling from rest. dv dt equals to 9.8, right? That is acceleration due to gravity. We know that the rate of cooling is proportional to difference in temperature. D capital T with time derivative is k times T minus T, so difference in temperature. In the above equations contain the function and their derivatives, right? So we have the derivative function as well as the function. So these equations are called differential equations. So the equations that contain functions and their differentials or derivatives are called differential equations. To solve a differential equation, example dy dx equals to f of x, is to find the expression for y as a function of x. That really means to undo the differentiation by means of an inverse process called integration. So that is what integration is, right? So it's the reverse of differentiation which we just did. Perfect. So I hope that concept is clear to you. So basically, what we are saying here is that if you are given the differential equation dy dx equals to f of x, as it could be in one of these examples, we know the rate of change. What we need to find is what is y, right? We need to find what is y. And you can do that if you reverse your operation. So y is equal to integral of f of x dx. So that is what integration is. Now in this particular sign, that is a sign for integral. It is elongated s. So here the operation of integration is denoted by the letter as shown here, elongated s. So that is the operator for integral. And dx tells you integration with respect to x, right? The function f to be integrated is placed between the integral sign and the differential dx, which is integrated with respect to x. That's what it means. This function f itself is called the integrand. So f of x is called the integrand. Okay, so these are a few basic definitions. And now we have understood that integration basically is reverse operation. So let's look into differentiation for a moment and see how it is a reverse operation and how we can get an integral from a derivative. Now let us have a look at reversing differentiation. So as you know, the gradient of f of x equals to x cubed is what? It is, the derivative is 3x squared. So you know 3x squared is derivative of x cubed, right? So if I ask you, if the derivative is 3x squared, what is going to be the function? That is what integration is, right? Reverse operation. So once again, the gradient of the function x cubed is f prime x, which is 3x squared. Reverse of this will be the function with gradient f prime x equals to 3x squared is f of x equals to x cubed, right? So as you can see, the reverse of this will be that if I have given the gradient of the function, which is 3x squared, then what was the function? Well, the function was x cubed. You could say that, right? Since derivative of x cubed is 3x squared. So that is what we're trying to say, right? So that is how differentiation and integration are related, right? So the reverse of this will be function with gradient f prime x equals to 3x squared is f of x equals to x cubed. The above statement is true. However, there can be infinite solutions, right? You know, it is not just x cubed which will work for the gradient of 3x squared. It could be x cubed plus minus many values which are constant, right? So in general, what we also know that if the function f of x is now, let us look into the operation of derivatives and see how integrals are related with it. Well, as you know, if I want to find derivative of x cubed, what is that? Well, the derivative is 3x squared. We know it for sure, right? Now, the other way to look into it is that if I'm given that the derivative is 3x squared, what is the function? Right? That is my question. Well, you could say the function is x cubed because x cube's derivative is 3x squared. But remember one thing, that that is not the only solution. If I am telling you that the derivative is 3x squared, what is the function? Then function could be x cubed plus any constant, since the derivative of a constant is 0, right? So that creates a problem. So it is not that simple. We cannot straight away write down the entire derivative as our solution, right? So we have to take care of the constant, right? So that is kind of important to understand. So the above statement is true, which is that the derivative is 3x squared, then fx equals to x cubed. That may be true, but not always, right? There may be some other functions which could also be true. So this is not the only solution. That is what we're trying to say, right? So now, the above statement is true. However, there can be infinite solutions. F of x is equal to x cubed plus c, whose gradient is 3x squared, right? So all the functions x cubed plus c will have the gradient of 3x squared, since the gradient of constant is 0, right? So that's important to understand. The gradient of constant is 0. So that gives you a hint that it is not a direct relation, right? It's not one-on-one relation. So by reversing differentiation, we are able to get general solution, not a specific solution, right? We are not very sure about a particular solution, right? So to give you an example, these are the graphs of x cubed plus c, right? So these are different graphs. All of them are parallel, right? And the derivatives for all these graphs is going to be 3x squared, right? So for all these graphs, we know that the derivatives of these functions is basically 3x squared. Is that clear? So the function could be x cubed plus c. Now, another thing important to understand here is that in this particular equation, you see we have used derivative and the function, and therefore it is called differential equation, right? So all these equations will be treated as differential equations. To solve this equation means to find the value of y. Is it clear to you? So in this particular case, the solution is y equals to x cubed plus c, right? So you could say that the solution of differential equation dy dx equals to 3x squared is y equals to x cubed plus c, right? Where c is any constant. Right? So that is a general solution. Is that clear to you? So that is how we provide general solution and this anti-differentiation, right? Now it is important to note at this stage that all the graphs shown have the same gradient, right? Since the derivative is constant 3x squared. The only difference is they are vertically translated, right? So vertically translated graphs have the same gradient. Okay. Now let's look into an example. How do we find a specific solution to our question? As we said in the previous example, the factor c comes because the derivative for a constant is 0. Now let's look into an example. Given dy dx equals to 3x squared minus 2, find the equation of the curve with this gradient function, which passed through a point 2, 1. So now we are given the gradient. We need to find the equation of a curve which has the given gradient, but which passes through a given point also. So since we are given a point, we are very specific about our graph. And so we have a specific solution. Okay. So now let's once again look into what is given to us. The differential equation given to us is dy dx equals to 3x squared minus 2. Now if I do antiderivative, then I can find from here that y should be what? Well, y should be x cubed because x cubed will give me the term 3x squared minus 2x, right, plus a constant c. So that becomes the value of y. Now it is a question of finding c. You can find c because we are now knowing a point on the graph, which is 2, 1. Substituting 2, 1 in the given equation, y equals to x cubed minus 2x plus c, as shown here, we can find the value of c. Rearrange, and then you get the value of c as minus 3. Substitute that to get our final specific solution to the differential equation, right? Is that clear to you? So what we notice here is that the arbitrary constant can be evaluated with some additional information. So in this particular case, the point on the curve was an additional information. Now let's look at the derivation of this particular formula for integration. So we'll now derive a formula for power functions. As you know, power functions are like a times x to the power of n, where n can be any integer. Now here we'll now explore differential equation of the form dy dx equals to f of x. Solution to these equations are called antiderivatives of f of x. So we'll take a case where f of x is equal to x to the power of n. Now n could be any real number in this case, okay? So we'll take n belongs to set of real numbers, okay? So the process of derivative or differentiation we saw, if I have x to the power of n, then we subtract the power, that is the first step, right? We multiply this with the power itself, and we subtract the exponent, right? So we have two operations to be done to x to the power of n to find the derivative of a power function. So we multiply by the power, which is n in this case, and less 1 from the power. So in exponent, we do take away 1 or subtract 1. So we get a derivative, which is nx to the power of n minus 1. Now, as we are saying, integration is reverse of differentiation. So what is going to be the reverse operation? So if I'm moving from this function in the reverse direction, we'll reverse all these operations. So now let us say we begin with n x to the power of n minus 1. Once we reverse, we should get x to the power of n, right? So first operation should be in the reverse order. Instead of less 1 from power, it should be add 1 to the power. So we'll add 1 to the power. This becomes n times x to the power of n. And now divide by the new power. New power is n, so when I do that, I get n x to the power of n divided by n. And these n's cancel. What we get is x to the power of n. So it really works, right? So that is how differentiation and integration work hand in hand. It's literally a reverse operation. Now there is only one problem, and that is derivative of a constant is 0, right? So that is one problem which we have to keep in mind. Now let us consider that this is the reverse operation for the power rule. In that case, if I begin with x to the power of n, then what happens? First step is we have to add power. So it becomes x to the power of n plus 1. And then the step is divide by the new power. So we get x to the power of n plus 1 divided by n plus 1, which becomes a rule for integration for a power function. Is that clear to you? So that is how we actually derive our rule. Now here we have to make one adjustment, and that is because the derivative of a constant is also 0, right? So since we know that the derivative of constant is 0, so the constant term disappears on differentiation. So what I'm trying to say here is if I have x to the power of n, and if I have a constant term added on this place, the result is still the same, since the derivative of the constant is 0, right? So when you reverse it, you should actually get a constant term. Makes sense, right? So that is to be adjusted. So that's what we're talking about now. So derivative of a constant is 0. So the constant term disappears on differentiation. This means that for any function f of x, we need to add the constant of integration at the end of the integration. In general, if you have integral of f of x dx equals to, it will be always a function plus c. Okay, so that is what it is going to be. So integral will always be a function plus a constant. Such an integral is also called indefinite integral. Indefinite since we are not sure about the value of c, right? That is why it's called indefinite integral. The integral function is family of vertical translated functions. So as you've seen in the previous slide, so that is the family of vertically translated functions. And that is how you will see the integral, right? So in general, it could be a set of graphs which are vertically translated. The integral function is family of vertically translated functions, as we saw earlier. To find a specific member of this family, we'll need additional information, correct? So here are some formulas which we can now remember. As we just derived here, if we begin with integral of x to the power of n, we know it should be x to the power of n plus 1 divided by n plus 1, right? So based on this, we have three different forms of looking into the same equation. So if dy dx is x to the power of n, then y equals to x to the power of n plus 1 divided by n plus 1 plus c, right? We can also write this in the terms of f derivative x equals to x to the power of n. Then f of x is x to the power of n plus 1 divided by n plus 1 plus c, right? Now, it is once again written in the integral form with the symbol. So integral of x to the power of n dx is x to the power of n plus 1 over n plus 1 plus c, where n cannot be equal to minus 1. Since we cannot divide by 0, right? So in the next chapter we'll learn what is the integral of such a function, which is 1 over x. So now it's kind of important to understand that n cannot be equal to minus 1, since it makes this denominator 0, right? Let's take a few examples now before moving forward. Remember these three ways of writing our integral function. So if we know that the derivative is x to the power of n, then the integral antiderivative is x to the power of n plus 1 divided by n plus 1 plus c, which is also written in these two different forms, but they mean the same thing. So here we have three examples. You can always pause the video and answer these examples. Find y for dy dx equals to x to the power of 5. So that is what solving differential equation is. So we need to find y. We'll do inverse operation, antiderivative. What do we get? Apply the formula, right? So that is the formula to get y. X to the power of n plus 1, we have to add 1 to 5 and divide by the increased power, right? And then you get your formula and the solution as shown. Since we are not aware of any other condition, we'll write C in this particular case. So it is a general solution. 2. Find f of x for f prime x equals to 1 over square root x. So 1 over square root x you could rewrite as x to the power of minus half, and then you can add 1 in the exponent and then multiply by 1 over the new exponent, right? So that is what this number is. So once you do that, you get your result, right? Now, it is easier to write this in the form of x to the power of minus half as written here, and then add 1 and then do the calculation. So minus half plus 1 is x to the power of half. So we get x to the power of half divided by x to the power of half to get the result, right? Plus c. So there you go. We have 2c. So when you rearrange this, we get 2 square root of x plus c as our answer, right? Okay. Now here is another example which says differentiate, it says find integral of x to the power of minus 4 dx. So you apply the rule, minus 4 plus 1 is minus 3. Divide by minus 3, right? So once you get that, plus c is your answer. Now let's try to understand the factor rule. In derivatives, we learn that if x cubed has derivative of 3x squared, then 5 times x cubed will be 5 times the derivative of 3x squared. So the multiplier works really like a multiplier, right? So that's what we're trying to say. So in case 2, we'll discuss the case of derivative of the function f of x equals to k times x to the power of n. Now this function, k times x to the power of n, when you find the derivative, you get k times n x to the power of n minus 1. So basically, you see that the derivative, if I have the function f of x times k, then the derivative will be f prime x times k, right? So from here you get an idea that when we do the reverse operation, you have to multiply the result by k to get your answer. And that gives us the next rule, which is integral of k times x to the power of n dx is k times the integral of x to the power of n dx. And we worked out that that is ratio of x to the power of n plus 1 divided by n plus 1 plus c, right? So you can now apply this formula and solve the following two questions, right? Now here is solution also given to you. So question number 4 is find y for dy dx equals to 5x squared. Well, applying the rule, x power gets added. 2 plus 1 is 3, and we have to divide by 3. So we get 5 over 3 and x cubed, right? So it's so simple as that. Now in this particular example, you're given 3x to the power of 4 plus 2x, and we need to find the integral. So integral of 3x to the power of 4 will be what? It will be x to the power of 5, 1 increase, and divide by 5. So we get 3 over 5 as a constant, and x to the power of 5 as the x component. Plus 2x plus c are the other two components for the same function. Now let's look into another type of an example. Now let us take the third case where the function is of the form ax plus b to the power of n. So if I have this function and if I want to find the derivative of this function, f of x is ax plus b to the power of n, then what is the derivative? Well, the derivative will be equal to, let's rewrite, this is incorrect. So the derivative of this particular function will be, you have to multiply by n times ax plus b times a, right? So n times a will come as the coefficient and the exponent will be n minus 1, correct? So you reduce the power of the exponent, right? Multiply by the coefficient of x and the power of n. So if I do the reverse operation of integration, in that case, what will be the scenario? Well, as we did for power function, we'll have ax plus b to the power of n plus 1 and also divide by n plus 1. Now here, since you are multiplying by a, you will again divide by a to get the original function, correct? So that becomes the reverse operation. You get the idea. So the integral of ax plus b to the power of n is ax plus b to the power of n plus 1 divided by a times n plus 1 plus c, correct? So plus c because of the constant having derivative as 0. So based on this, we have two questions here. I'd like you to pause the video and answer these questions. So find y for dy dx equals to 5x minus 3 whole square. So when you apply this particular formula, 2 plus 1 is 3. So your power will become 3. You have to divide by 3 and also by 5, right? And you get your result. So that is how you get your result. And of course, plus c will be there, right? So you get the answer, which is 5x minus 3 whole cube divided by 15 plus c. Now let's take the next example, which is 7x plus 2 to the power of minus 3. We need to integrate it with respect to x. So the power gets added first. So minus 3 plus 1 will give us minus 2. So we get minus 2 here. We have to divide by minus 2. and also by the coefficient of x, which is 7. And you get your result, right? So application of this formula gives quick results, plus c, of course, since derivative of constant was 0. Now in these cases also, we could have specific solutions if we are given some boundary or initial conditions. So in example 8, find f of x given that the derivative is 5x to the power of 4 minus 4x and f of 2 is 4, right? So on the curve at 2 the point is 4, the value is 4. So we are given the derivative, we'll do antiderivative and so find the function itself. So integral of this particular function is what? 5x to the power of 4 minus 4x, x to the power of 4. It increases by 1, so you get x to the power of 5 divided by 5, right? So that 5 and this 5 will cancel, and what you get here is, and then the derivative of this will be 4x squared by 2, right? So that would be the derivative for this function, which I have written here. So the derivative of the first one is 5x to the power of 5 divided by 5 minus 4x squared by 2 plus c. Simplify this, cancelling the 5's, we are left with x to the power of 5, and then here you could cancel with 2 minus 2x squared plus c. So that is how you're going to get the integral for the particular function. Now, we are given the initial condition as f of 2 equals to 4. So we can substitute the value of 2 for x and 4 for f of 2. Once you do that, you can find the value of c. So in this particular case, 4 is equals to 32 minus 8 plus c. You can rearrange c equals to 4 minus 24, which is minus 20. So now the integral is x to the power of 5 minus 2x squared minus 20. Perfect. So that becomes the function whose derivative was given to you, right? The next example here is state two different integrals of the function f of x equals to minus 6x squared. Well, let's apply the rule. Once you apply the rule, here's the integral of minus 6x squared dx. Add the power, it becomes 3, divide by that 3, right? So that becomes your rule, plus c. So when you divide 6 by 3, you can simplify and write the answer as minus 2x cubed plus 3. Now the question here is, state two different integrals for the function. Well, give different values of c. So one I kept 1 and for the other I kept 0 as the value of c. So I got two different integrals as shown here. So one of them is minus 2x cubed plus 3. The other one is minus 2x cubed. Perfect. Part B is the functions are parallel and are translated vertically. Well, that is for you to understand. How are they related? These functions are parallel, right? And they're translated vertically. That is how they are related. Now here is example 10. Find integral of square root of x minus 2 divided by x squared. Now to solve this, you need to express each term in the form of kx to the power of n and then apply the formula, right? So you could individually divide both the terms by x squared and simplify, and that is what we have done. So we have integral of square root of x minus 2 over x squared dx. You could write this as integral of square root x over x squared minus 2 over x squared. Now x to the power of half is square root of x, right? So we get x to the power of half minus 2 times x to the power minus 2, and then you get x to the power minus 3 by 2 minus 2 times x to the power minus 2. Now once we have these terms individually in the form of kx to the power of n, we can apply the formula and get the answer, right? So now in the first term, the exponent is minus 3 by 2. We are going to add 1 to it, and whatever you get, divide by the same, right? The second one is minus 2. When you add, it becomes minus 1. you have to add and divide by the same term. So that is the process you have to do. Add c, the constant. Now you could simplify this without any problems, I hope. So basically that minus 2 goes in the top, and so we get minus 2 over square root of x plus 2 over x. Correct? So that is how we get our solution. So the integral of this particular function is minus 2 over square root x plus 2 over x plus c. Here is question number 11. Find integral of 3 minus 2 square root x whole square dx where x is greater than 0. Now in this case again the strategy is same. You have to write each term as a power term, and you could expand this a minus b whole square, right? So you can use a minus b whole square and expand, which is basically equal to a square minus 2ab plus b square. So you can use this formula and expand as it has been done here. So you start with this function, expand, get the trinomial. Once you have three terms, apply the power rule and write down your answer. You may have to simplify, correct? So that is how you could actually do it. Now, if you have fractions, this is the way to do it. You can actually first solve this portion, correct? So 3 over 2 is in the denominator. It comes in the numerator as 2 over 3 as shown here. So what you get here is minus 12 times 2 over 3 x to the power of 3 over 2. Is that clear to you? Now once you simplify, then you write the answer in the simplified form and post. Last three examples to go. Here is question number 12 for us. We need to find the integral of a over ax squared plus ab dx. We are already given that this integral is 2 over x minus 12x plus c. We need to find the value of a and b, right? So the question here is to find the value of a and b when the integral is given to us, right? So let's see how to do it. So the integral of this particular function, you will apply the power rule and write down. So a over 3x squared, a is a multiplier here. So 3x squared, so just keep 3 here, x in the denominator, so minus 2. So when you add 1, you get minus sign, and x to the power minus 1, so it comes in the denominator, right? ab integral is abx plus c. So you get the integral. Now, we know we need to find the value of a and b, so what we can do here is compare the coefficients, right? So if you compare the two equations, then in that case, a over 3x should be equal to 2 over x, right? They are equal. Similarly, these two are equal. So when I equate minus a over 3x equals to 2 over x, so I get the value of a as minus 6. Now, product of a, b, I can substitute now minus 6 for a and then find the value of b, right? So I hope the steps are absolutely clear. Now let's take another example, which is the gradient function of the curve with minimum value of 20 is f prime x equals to 6x minus 18. Find the equation of the curve. So we are given the gradient. We are also given a condition, minimum value of 20. So we can specifically find the curve, right? So since the minimum value is given to us, we know the critical number is when the derivative is 0 or it does not exist. Now since we are working with polynomials, a stationary point will be considered as a critical number. Now here, the derivative is 6x minus 10 and it is equal to 0 for x equals to 3. So we get a value of x, right? So the minimum point is at 320 since we are saying that the value is 20, correct? So at 3, we have the vertex of the parabola, which will be 320, right? As written here. So the general solution of the given equation, 6x minus 18 is what? Well, x squared divided by 2. When you divide 6 by 2, you get 3. So that's perfectly fine. And minus 18x, that's correct, plus c. So that becomes the function for us. Now we need to find the value of c. To find the value of c, we can definitely use our point, which is 320. Substituting 3 for the x value, as you can see here, right, and the y value is 20, we can now find the value of c. So you can rearrange and solve. C comes out to be 47. Perfect. And now, once you have c, you can write down the equation for the curve, right? Now here is the last question on integration. The question is question number 14. The gradient of the curve is 4 minus x. Point P, 2, 9 lies on the curve. The normal to the curve at P meets the curve at Q. Find the coordinates of Q. That's the question for you. You can always pause the video and answer the question. Well, we are given the gradient at the curve, so that means f prime x is equals to 4 minus x. From here, we can do antiderivative formula and find what the function could be. So f of x is 4x minus x squared by 2 plus c. Now to find the value of c, we can use the given point, which is 2, 9. So substituting 2 for x and 9 for y, we can find the value of c, right? So once we find the value of c, which is 3 in our case, we know the function. And in this case, the function will be 4x minus x squared by 2 plus 3. So that becomes the function for us. So that's one part. Now we need to find the equation of the normal, since we need to find the normal intersection with the parabola in this case, right? So the normal at P will be what? We know the derivative. So in the derivative, we'll substitute the value 2 and we get the derivative is 2. Since the derivative is 2, normal should be negative reciprocal. So the normal will be minus half, right? So that is how you have to do it. Perfect. Now once you know the normal, you can use y equals y minus y1 equals to mx minus x1. Simplify this particular equation and get your result. So that is how we could get the result of the equation of the normal, correct? So once you get the equation of the normal, we know the graph equation and the normal equation. So these two will give us point of intersection, right? So these two will give us point of intersection. So those are y values. We're going to equate these y values and then find the point of intersection. So the left side is one of the equations, the right side is the other equation. Bringing all the terms together will give you a quadratic equation. So once you have a quadratic equation, it can be factored and solved, right? So that is how we are going to actually do it. So as you can see here, we have a quadratic equation in this case, which can be simplified and written as x squared minus 9x plus 14. 7 times 2 is 14, both negative, will add up to minus 9. So we get a solution of x equals to 7. Well, x equals to 2 was originally the point P, right? So Q should be at x equals to 7. Substitute 7 for x and calculate y. You can use the second line, simpler equation, which is of the line, to calculate this particular value, right? So we get y value equals to 6.5. So the coordinates of point Q is x is 7, y is 6.5, coordinate is 7, 6.5. Perfect. So that is how we can actually do some questions based on integration. But with this video, you get an introduction to what is integration, how do we use antiderivative to integrate the functions. So whenever we are given the derivative, we can get back the function. And the process is reversing the derivation process, and that is why we are calling it antiderivative. So these examples will help you to understand the topic better. So we'll take up the next chapter where we'll consider definite integrals and then move along. I hope it is absolutely clear. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.